Going live. Hello, everybody, and welcome to the IGDA Helsinki IGDA Finland event of May. This is the first event. We're doing a couple of things a little differently this time. But first, let me introduce myself. I'm Hedley. I'm from the IGDA Helsinki, also the chair of IGDA Finland. Really happy to have you all here tonight to hear some good insider info on those AWS game servers. Like I said, we're doing some things a little different. We have 3 events this month. The first one being today, and then from now on every week. So next Tuesday, and then Tuesday after that, we have an event with AWS. There's different topics coming every week, so stay tuned. There will, I swear, and I promise that there will be at least one, if not more, that will interest you personally. And after that, it'll culminate into the Nordic Games Conference, where we will have a mentorship cafe. So if you are so inclined, we're more than happy to see you there. But that's kind of me. Before we go into the hosts themselves of the event, the AWS people, I'm just going to quickly say a little shout out, if you will. So this is IGDA Finland doing this, but we're doing this for the first time in collaboration with IGDA Sweden. Hey, Sverige, hello Sweden. Nice to see you guys as well. And we're hoping to do more and more with Sweden in the future. And if you stay tuned, we will, at the end of this year, hopefully have one big event, just IGDA Finland and IGDA Sweden, working together to kind of bridge the gap between all the devs between these two wonderful countries. But yeah, that's kind of the IGDA hellos, I have to say. I think I've talked enough by now, so I'm gonna do some streaming magic here and throw the AWS people to you, and they will introduce themselves. Thank you, and here you go. So, who wants to start? I think on the screen, Allison is the first one on the left, so maybe Allison can start.
Sure, I can start. I'm Allison Bylas, and I do business development for AWS Game Tech here in the Nordics and the Baltics. So that's around partnerships and getting new users on the platform as well.
Thank you. We're actually going to skip Juho a little. It's a little funny, but he's going to be the one who's presenting, so he's going to go last. So how about Toni? We go with you next.
Sure. Hi, I'm Toni Syvänen. I'm a game tech solutions architect here in the Nordics. So answering all kinds of technical questions you have about how to use AWS services for your game backends and game servers, and how in general look into architectures on how to make your games go global easily.
Wonderful. Thank you very much. And then we have, I was going to say last but not least, but Juho is the lead. But yeah, Ed, you go.
So hi, my name's Ed Smith. I am the account executive manager here in the Nordics for Game Tech. I've been in Game Tech Nordics for about 5 years now, AWS for about 7. Play probably a little too much Paradox games, as you guys might be able to tell from my posts. That's me.
Wonderful, thank you. And then finally, we have the Juho, the man himself. So
right.
Go ahead. The floor is yours.
Yeah, thanks. So yeah, I'll just get the presentation started. So yeah, welcome everyone. Nice to be the first one to do a session on a number of sessions that we're going to do at AWS. So today's topic is game server hosting on AWS. My name is Juho Jantunen. I'm a senior solutions architect in the AWS Game Tech team, based in Helsinki actually. And essentially, similarly to Toni, I'm working with our customers across Europe to help them build games on AWS to put it short. So making sure that those backends are well architected, looking into best practices, and making the best use of our services. A bit of a background. So I started making games at the age of 10, roughly, when I got my hands on a copy of the Games Factory, and then moved on to things like Quick Basic and C++ and stuff like that. I actually been making games professionally. I started like 12 years ago, roughly. So we made PC games, some console games as well. I did some teaching as well, so teaching game programming, software development, and then moved on to mobile games. And this is when I was introduced to AWS. So building game backends, game server hosting for a number of mobile games. And yeah, that's essentially what brought me here. So yeah, session is on game server hosting on AWS. I'll jump into the agenda. So I want to start a little bit with why AWS for game server hosting. What do we have? What are the benefits of using the cloud for game servers? Then I'll talk a little bit about AWS global infrastructure. So essentially the regions, the data centers that we have across the world, and how you can make use of these to provide a low latency experience for your players. Then I'll talk about some sort of game server hosting base. So what are the things that you need? You obviously need the actual game servers, but typically you need other things around that as well. So I'll talk you through that, and then jump into the key game server hosting options on AWS. So we had a very broad set of services, and there's a number of ways you can host game servers on AWS. I'll talk you through them quickly, and then focus on the managed offering. So we have two different services. First one being GAMELIFT hosting, and the second one GAMELIFT FLEETIQ that I'll talk you through, and then some getting started tips and Q&A. Actually, yeah, I'm missing one bullet, so I'll quickly talk about a few solutions that we have available in GitHub that you can use to help you get started. All right, so why AWS for game server hosting? Well, there's a few key things. So we take games industry very seriously, and this is why we have a specific game tech vertical as well that all of us in the call are part of. And we purpose-built managed services for game server hosting specifically at the moment, but obviously we have the ambition to expand that. And so we have technology that is built for the games customers specifically. Also, the global infrastructure is a key thing to highlight. So we have 25 regions, so essentially 25 different regional locations around the world, which consist of 80 availability zones. I'll talk about this in a while, but those are essentially data center clusters, and even extending this to sort of expansions of the region, so to speak, with something called local zones. And this means that you can bring your game servers very close to the players, which is critical to provide a low latency experience. Trusted by customers, we have a lot of reference customers in the games industry, think customers like Epic Games, Ubisoft, Supercell, Rovio, and a lot of others. So you have access to a number of case studies how other customers are using AWS. Obviously, you need the actual virtual machines that we call instances or instance types on AWS. And we provide a broad set of different instance types. So depending if you're more like compute heavy or memory heavy, or you need high throughput networking, you can choose between the different instance types for your game servers. And then wanted to highlight the networking, which is super important for game server hosting. So we provide instances with up to 400 gigabits per second networking, and that already tells that you have the sort of the networking bandwidth that you need to host your game servers. All right, I wanted to take one case study, one example here. So, and this relates to game servers specifically. So Epic Games uses AWS for Fortnite, which is probably familiar to most of you. And the most interesting point from this quote from Chris, who is the director of platform, is that the demand in capacity varies a lot. So at peaks, they need 10 times the capacity that they need in low peak. And this means that first of all, they need to be able to scale to that capacity, which is obviously massive with 200 million plus players. I think it's a lot more at the moment. And also it means that they want to scale down. So they want to only pay for the resources that they need when they are not at that peak. And if you have a live game, you know there's a sort of daily variation, there's a weekly variation in the usage. And obviously there's things like updates, or events in the case of Fortnite that affect a lot the usage. And this is one of the benefits of the cloud. On AWS, you can scale to the demand and only pay for the resources that you need when you actually need them. All right, so moving on to the global infrastructure. So I wanted to cover this because it's good to understand how our global infrastructure works, and it's actually pretty essential for game server hosting. So if you look at the regional expansion, we started off on the first 5 years, we had 4 regions. So 2 in US, East Coast and West Coast, Ireland and Singapore. So those would be the blue dots. In the next 5 years, we added 7 more regions, which would be the yellow dots. And actually, between 2016 and 2020, we added 14 more regions. So we're expanding at an increasing pace. We already have 6 more regions announced. And the idea, obviously, is to be as close to the customers as possible. In addition to this, we actually have, as I already mentioned, the concept of local zones, which is relevant to the game server use case. So we already have 5 available, some of them in preview, 12 more announced. A lot of those in US. So if you have players in US, you might know that they might have very significant distance to the East Coast and West Coast. So we're sort of extending this with the local zones. So these are sort of extensions to the region, and this is obviously a concept that we're heavily investing in as well. And all of this relates to the player experience. So being close to the players means that you can provide a good player experience. All right, a little bit diving into what a region looks like. So a region consists of something called availability zones, which are essentially data center clusters that are isolated from each other. So they are meaningful distance apart, but they still have like a single-digit millisecond latency between them. So if you have a database in one AC and a virtual machine in another one, they can still communicate effectively, but you can achieve high availability by deploying your resources across availability zones because they are physically isolated from each other. A lot of our services already do this for you. So we have a lot of sort of serverless and managed services, things like DynamoDB and NoSQL databases, that they make use of the availability zones automatically, or S3 or object storage. Also, the GameLift service makes use of these. But even if you build something yourself on top of virtual machine infrastructure, we have good ways for you to sort of make use of all of these availability zones. Another thing to highlight here is that we have a fully redundant transit centers for the networking in all of the regions. So it means that it can cope with the failure of either one at any given point. And this gives you a really reliable networking connectivity, which is also obviously important. All right, so let's see what we need for game server hosting. If you have been hosting multiplayer session-based games, you already know most of this. But I just wanted to recap to give you some insights on the key things. So obviously we need the actual servers. This is sort of given. It's relatively simple. So typically you have the game servers hosted somewhere. In this case, we'll discuss different options on AWS. And they have a public IP, they have some ports open to the world, and this is how the players connect over TCP or UDP. It's not typical to have anything like load balancing in between the players and the game servers because these are stateful sessions. It's very hard to do load balancing. Also, you typically don't do any sort of proxying of the TCP or UDP packets. I have some customers doing this. It adds a layer of security to some extent, but it also obviously adds some complexity. Okay, so this is how we host the game servers. Another key thing that you need is a backend service. So your players can't just sort of guess like where is the game server located. They need to be actually able to connect to it and figure out where it is. And this is typically done with a backend service. So you have a backend service hosted somewhere. The players ask like, give me a session. Maybe they send in a matchmaking request, or maybe they just ask for a session for me and 2 of my friends. And then the backend service will send in an IP and a port, typically also some sort of session token that the player can send to the server to validate that I'm actually, I should be connecting to this server. And we have a number of ways you can build backends on AWS. I'll just briefly cover some of the key ones. So the one that I have used in the example solutions that I'll be sharing is something called API Gateway and AWS Lambda. So Amazon API Gateway is a managed service where you can host a REST API. So essentially you have HTTPS requests, things like request matchmaking, get my match status, get player data, and stuff like that. So you define that on the API Gateway level, and then you typically back it off with AWS Lambda functions, which are serverless compute platforms. So you author the code in languages such as Node.js or Python or C# or Java. You upload the code to Lambda, and we take care of the compute infrastructure. We take care of the scaling and you pay with 1 millisecond increments of the actual compute that you use. So this is a very effective way to build backends because it's fully managed. You don't need it gives you very little operational headache. Also scales from your first user to 1 million users, and you typically don't need that sort of TCP or UDP connectivity to the backend service itself. Obviously, there's other ways to do this. So you have the traditional sort of virtual machine structure on Amazon EC2. Definitely works well if you already have the sort of you're already using tools that make use of like a more traditional virtual machine infrastructure, and you want to manage load balancer. We have something called elastic load balancing. So this is a very typical way. Or if you're building things with containers, which is I think even more common nowadays than just directly on VMs. You can use Amazon Elastic Container Service, which is our AWS native container orchestration platform, or Amazon EKS, which is a managed Kubernetes control plane to actually host those containerized services. And then the last one I wanted to highlight is AWS AppSync. So if you're into GraphQL, using WebSockets and more of like an event-based architecture, you can use AWS AppSync with AWS Lambda and even connecting directly to data sources. So yeah, a lot of options there, but we got you covered depending on how you want to build your game backend. All right, the next thing you need is a game session database. So obviously, like you have game servers, you need to know what game sessions are they hosting. Are they ready to host sessions? Are they in use? What is the player count? Are they healthy? And for this, you need some sort of storage or database option. I would say the two most common ones are using either Amazon Elasticsearch for Redis, which is a managed Redis deployment and in-memory cache, very sort of fast for key value data, or Amazon DynamoDB, which is a managed NoSQL database, fully serverless, scales based on demand. So these would be the typical options. Obviously, we have a managed SQL engine as well called Amazon RDS, where you can host MySQL databases or MySQL databases or other database engines, or a native database engine called Aurora. All right, we'll talk about the GameLift services in a bit, but both GameLift Hosting and GameLift FLEETIQ, which are the two options that you have, both of these actually support managing game session database for you. So don't need to worry about that if you're using one of these services. The next one is player session database, very similar. So it's sort of just an extension. You need to be able to say like what player sessions have been created for this game server. Have the players already connected? Did they connect in a defined time frame, or should we sort of release that player slot for someone else? And again, the same database options would be used for player sessions. And from the GameLift options, GameLift Hosting, which is the more managed option, it manages the player sessions as well. So it will give like a player session ID for the player or the client. The client will send this to the server. Server can validate that this is the correct player session. So it sort of manages all of this for you. And then the last thing that you might need and very commonly need for session-based games is matchmaking. So your players like ask, okay, give me a match on this map. I want to use this character. The backend service typically will do things like fetch the player skill from a database or some other parameter that is used, maybe ELO ranking, and then send a ticket into your matchmaking service that then crews multiple tickets together, creates a match, provisions that match from your game servers, and sends the IPM port back to the players. You can build this yourself. It's sometimes actually can be a complex thing to build, but we have a managed option for that as well. So within Amazon GameLift, we have something called FlexMatch. So it's a JSON-based rules language where you can define very complex or simple. Typically, simple is better for matchmaking, but also complex rules for your matchmaking. So things like what kinds of teams you have, what are the sizes of those teams, what are the latency requirements, what are the player skill level requirements, should they be close to each other, stuff like that, and also sort of relax those rules over time. So let's say we didn't find a session in 5 seconds, we actually accept a bit bigger sort of distance between the player skill. So all of this can be defined in GameLift FlexMatch, fully managed service, and it integrates directly with GameLift Hosting. Or you can use it also in standalone mode. So if you're hosting your game server some other way, you can still use FlexMatch just in the standalone mode, and then you sort of manage the game session placement yourself. So a lot of flexibility within that service as well. All right, so let's look at what game server hosting options on AWS are. So just to recap, we are talking about session-based multiplayer games here, because game servers, sometimes you talk about game servers when you talk about game backends, but here we're talking about session-based games. So first of all, we have the managed services. I will dive deeper into these in a minute. So Amazon GameLift Hosting, which is a fully managed one, and Amazon GameLift FLEETIQ, which is a more lightweight, which gives you more flexibility on how you deploy and manage your game servers. Then we have container hosting, which is actually increasingly popular. So it's especially running your game servers on a Kubernetes cluster is more and more common. We have a managed Kubernetes platform called Elastic Kubernetes Service that you can use. Actually, over 80% of the Kubernetes workloads that run in the cloud, they run on AWS. Or if you want a solution that is fully integrated into the AWS platform, we have Elastic Container Service that works with the same APIs. You can use the same CloudFormation templates for infrastructure as code, and it integrates really well to the other AWS tooling. So if you want to go the AWS native way, then it would be Elastic Container Service. And then with both of these options, you can either decide to host the virtual machine infrastructure yourself on EC2. We have good ways to obviously do that and scale it. Or you can choose us to manage that for you and use AWS Fargate, where you just provide the container images, you say what kind of resources you want, and we manage the underlying infrastructure for you. And you pay for those containers, not for that VM infrastructure. And then obviously, last but not least, you can choose to use just virtual machines on Amazon EC2, decide your instance type, and make use of AWS auto-scaling to scale the fleet of instances to your needs. This is really good if you already have the tools, proven technology. You want to make sure that everything works as it used to work. Or if you're migrating an existing solution to AWS, you have your game servers running on a data center, but you want more flexibility, you want more scalability, you can migrate it to AWS and use EC2 infrastructure with all the scaling. You don't need to make massive changes to how you operate things. All right, so let's talk about the two different managed options that we have. So first of all, GameLift Hosting. This is a fully managed game server hosting option. Some key things. So first of all, what it does, it deploys, operates, and scales dedicated low-cost servers for system-based multiplayer games. So it manages a lot of things for you. Essentially, what you do is that you integrate the GameLift server SDK into your game server build. Typically, this is like a headless Unity build or headless Unreal build or your custom C++ game server. So we provide C# and C++ SDKs. And then you upload that build to GameLift, and then you define the resources, the fleets, and the other resources, and we manage those for you. Target is to provide low-cost game server hosting. So we do this with a number of ways that I'll talk in a while, but mainly scaling the fleet exactly to your demand and providing the option to use our excess capacity through spot instances that give you a significantly lower cost than the normal on-demand instances. But I'll talk about that later on. Low latency. So you can deploy up to 21 regions around the globe. So not all of them, but almost all of them at the moment. And obviously we're extending. So it means that you can do latency-based placement of game sessions using the GameLift service. So you essentially, your clients send their latency information to your backend. Backend sends this to GameLift, and GameLift decides, okay, these guys should be playing in US East Coast or West Coast or in the Ireland region. Or it might be also that you use the matchmaking service where it actually groups people who are close to each other and places them on appropriate regions. Then high availability. So GameLift Hosting makes use of the availability zones and hosts the game servers across multiple availability zones in all the regions. And then flexibility. So you can use this on different layers. So you can, the lowest layer is essentially placing sessions directly on the fleet in a specific region. Then we have the next layer where you place session across fleets on multiple regions, and then the top layer is the matchmaking component where you just place everything through those matchmaking tickets. All right, so diving into this a little bit more. So we have a game backend here. It's very similar to what I talked about on the serverless option. So the game client calls something called an API gateway, sort of request game session or request matchmaking. API gateway triggers a Lambda function that actually calls the GAMELIFT APIs to send in that matchmaking ticket or request the provisioning of a game session. We are authenticating the players using a managed service called Amazon Cognito, which comes in a few flavors. So you can have your player identity stored in this service. Actually, you can also use external identities with it. So you might have your Google identities or Facebook or Apple, or even integrate things like Steam through custom mechanisms. And then we actually protect the layer, this API already with something called AWS Shield. So this is something you get out of the box. It mitigates most of DDoS attacks for you. And essentially what is left is the layer 7, sort of the HTTP level attacks. And also for that, we have a service called AWS Web Application Firewall that you can configure to mitigate those as well. Okay, so we get the game session and the client gets the IP. So we connect directly to servers hosted on the GAMELIFT service. If we zoom out a little bit on from the backend, so we have it in a single box here. Typically, this is on AWS. It can be a serverless backend or a container-based backend, but it can be technically somewhere else as well. So we connect the backend service to typically to a matchmaker. So you have the FlexMatch component here if you want to use it. If you don't need matchmaking, you can connect directly to something called the queue. And the thing that the queue does is that you ask the queue to place a session for you. It will look at all the different fleets in different regions that you have deployed and select the best appropriate region for these specific players or this specific player group. We recently introduced something called multi-region fleets. And essentially what multi-region fleets does is that you don't actually even need to deploy these separate fleets in different regions. You just deploy the single region and define the other regions as locations for that fleet. So you only upload the build once, and you can deploy up to all the 21 regions across the globe. So that's pretty easy way to make a global game server deployment. All right. Yeah. So if you look at cost, if you've done peer-to-peer matchmaking, peer-to-peer game sessions, you know that it's free. It's not super reliable. You don't have the authoritative game servers. But obviously want to mitigate this a little bit. So on GAMELIFT, we have obviously the sort of the scaling of the capacity based on needs. So if you are in an on-premise environment, your capacity needs to be as much as your highest peak. So you need to be provisioning for this peak, and it might go over. So then you're sort of under provisioned. Often happens as well. And actually your player traffic varies over time. So you're essentially wasting money on resources that you're not using. What GAMELIFT hosting does, it manages this for you by scaling the fleet based on a simple configuration. So you say like, I want to have 15% of my game sessions always available for players. You can change that over time to sort of fine tune it, and you only pay for the capacity that you use. Another thing is instance packing. So in a traditional on-premises data center environment, doesn't really matter where your sessions are placed because you're always paying for those resources. On GAMELIFT, you obviously want to pack them as tightly as possible, and GAMELIFT hosting manages this for you. So let's say I have a specific instance type, let's say a C5 large, a compute-optimized instance type. I define in my fleet that I can run 4 game servers processes on this instance. GAMELIFT will try to always pack the game sessions tightly and make sure all 4 are used before using other instances, and then it can scale down to remove those extra instances from use. All right, quickly a little bit on how the placement logic works. I touched this topic already. So in this example, we have 2 regions in use. We have US West Coast, US East Coast, and a request comes into the placement queue. I need a game session for this group of players. Here are their latencies to these regions. The queue will pick the one with the lowest latency, obviously, first. And then it will after that decide like which fleet to host this in, because you can have multiple fleets behind the queue. The reason for multiple fleets is that you might want to make use of the spot mechanism. And I'll explain it quickly. So spot instances mean sort of the excess capacity of AWS in the regions that you can get with a significant discount. So it's 70% or even more less than on-demand instances. The catch is that they might be interrupted if they are needed for that on-demand capacity, and you get a 2-minute warning for this. What GAMELIFT does, it actually tries to estimate the risk of that interruption. And if it estimates this instance is not like to be interrupted, the session is placed on a spot instance if you have a spot fleet. And if it's likely to be interrupted, it actually falls back to your on-demand fleet. So it's good to have both configured. And this is especially good for sessions that are shorter. So if you have like a 5-minute, 10-minute, 15-minute, maybe 20-minute session, it's probably very viable option. And you, in the rare case of that interruption, you can sort of manage it. You get the 2-minute warning. If you have very long-running sessions up to hours, typically you would just go with the on-demand capacity. And then obviously, if there's no capacity in the region, it can even fall back, so to like a regional fallback to the other region as well. All right, so that was managed GAMELIFT in a nutshell, pretty quickly described. But if I sort of recap on a few things, so essentially you have your game server build. Typically it's headless Unity or Unreal build. You integrate the GAMELIFT SDK, upload the build. You create a fleet, define like which of the regions I want, and then you decide, will you need a matchmaker? Do you want to use the queue logic and so forth? And all of these resources are managed for you. All right, let's look at the other service. So we have another service within the GAMELIFT portfolio called GAMELIFT FLEETIQ. It gives you a bit more flexibility. So it has the same spot viability algorithm that I talked about. So it actually evaluates, is it viable to run on spot? And this makes it possible to use spot instances for game servers. It also has a simple API layer for game system management. So the game servers sort of register to FLEETIQ, and FLEETIQ understands like what game servers do I have, and it can claim a game server for your backend for a group of players through the API. You can use your existing tools. So as opposed to a GAMELIFT hosting, you own the deployment of the game servers. You can deploy them as containers. You can deploy them on VMs directly, but you need to manage that. You manage the lifecycle of those game server processes as well. So it leaves the game server management at your hands. You have more responsibilities, but you get more flexibility as well for some use cases. And it supports the container platform. So you can use this together with Elastic Container Service or Elastic Kubernetes Service. Both work together with FLEETIQ nicely. All right, so let's quickly look at how this goes. So with FLEETIQ, we create something called a game server group. If you're familiar with AWS resources, you've seen auto-scaling groups before. So this is a fleet of EC2 instances. So a game server group maps one-to-one to an auto-scaling group, and you can define multiple instance types. So the reason you would do this, so here we have like C5 large, which has a specific compute and memory, and then C5X large, which has double of that, and so forth. The reason we're doing this is that we make maximum uses of the available spot instances when they are available. So just sort of diversifying those instance types. And then those instances are spawned to the auto-scaling group, and then you decide how you host the game servers on them. So this is something you need to deploy. Do yourself. There's ways to do this. So we have things like code deploy, which is a service to deploy code to your instances, or you can make use of the user data of those instances to sort of spawn the instances. You might have a pre-baked image of the virtual machines that has your game server build, and you just sort of start them when the instance launches. All right, if we dive into this a little bit more. So yeah, we have this auto-scaling group, a fleet of instances. Typically, as with managed GAMELIFT, you want to run different amounts of game servers on a specific instance type. So C5 large, we are running 2 different game sessions, obviously with the same IP, but different ports. Another thing you need to do is use the AWS SDK on the game server. So we have AWS SDK for a number of programming languages, I would say most of them. So whether you're using C++ or C# or Node.js, Python, Go, whatever, we have the SDK. So you integrate the SDK to your game server build, and then you communicate with GAMELIFT FLEETIQ, so essentially with the game server group that you created beforehand. So the game servers need to register themselves. They need to update their status, so their health, and also say that, okay, I'm now in use, someone connected. And when they're done, you typically deregister, and commonly you terminate the process as well to avoid any memory leaks, and then have some automation to spawn up new ones. So that's also something you need to build yourself with FLEETIQ. It's done for you in GAMELIFT hosting. And then your backend service, it can be a serverless backend on AWS, it can be some other backend, uses the claim game server API to sort of ask for a game session, and FLEETIQ manages the game server session database for you. So it will sort of provision it and expect the players to connect within the next 60 seconds or free it up. Yeah, when you call this, a session is provisioned for you. It uses the FLEETIQ spot viability algorithm, so the same one as we have in GAMELIFT hosting. So to decide, like, should I host this on spot? Should I host this on demand? And decides between those options. You can also obviously have just on-demand fleets, so that's always available. And then another thing that FLEETIQ does, it on the fly modifies the autoscaling group. So it will see that, okay, C5 large is not a viable spot option. I'll terminate those once the sessions are done, and replace them with C5 2x large that is more available. Or it will actually replace everything with on-demand in the rare case of none of these being viable for spot. So FLEETIQ manages this for you. All right. So yeah, those were sort of the game server hosting options in general that we have, and then a bit more dive deep into GAMELIFT hosting as well as GAMELIFT FLEETIQ. We have a few example solutions available. I won't dive deep into these today, but I'll just show you them, and we will have the links available in the chat later on, so grab them from there, easily searchable from GitHub as well. So the first one is for GAMELIFT hosting. Sorry for the number of icons on the base. It can be intimidating, but actually this is pretty simple to deploy. It's an example built by me, so you can always reach out to me if you have any questions. The way it works is that you as a developer, you deploy all of these resources with infrastructure as code. So infrastructure as code means that you have typically a YAML template that defines all of your infrastructure resources, and then you use the AWS command line tool to deploy those stacks and update those stacks. So the stack state, the state of your resources is stored, and you can also have your sort of instruction version control with those templates. So we're deploying the backend service with something called serverless application model. It's a very simple way to deploy this huge set of resources in a very short YAML template. We're using CloudFormation for the GAMELIFT resources, so defining another YAML template for CloudFormation, and deploying those with CloudFormation. And then we're using the AWS CLI to upload our build to Amazon S3, which is our managed object storage, where GAMELIFT fleets will then pick those builds and sort of start the process. And players will connect to the backend, so they get an identity from Amazon Cognito, which I mentioned before. This is a service for managing user identities, and then they will use this identity to securely access an API gateway and invoke a backend function to sort of request matchmaking. So this example has the matchmaking component, the queue component, the fleet component, and all of the backend service functionalities as well. So this is why there's a lot of boxes on the slide. But if you go to the repository, it has simple deployment instructions. You have some initial steps. So it's using Unity on server and client side. So you need to have Unity installed. You need to do some configuration, install some of the AWS tools, and then you just sort of deploy the resources and test it out on your AWS account. The other example that I've also built is for FLEETIQ. So something similar, but a few differences. So this one makes use of the Elastic Container Service. So it's, as it's very popular to use containers for game servers, I wanted to build this kind of example. So we are running a FLEETIQ game server group that hosts a fleet of EC2 instances. And then I register those instances to Elastic Container Service cluster. And then I have a service running in AWS Lambda that essentially spawns game server processes as easiest tasks. So easiest tasks are essentially a single container or a group of containers. I just have the single game server container in this example. And the game server is a headless Unity server again that registers to FLEETIQ. So FLEETIQ knows of those existing sessions, and FLEETIQ will also scale the fleet automatically, and then the Lambda function will just spawn servers accordingly as tasks. And then when the players request an identity, again from Cognito, they make a request to the backend through API gateway. They will get a session through the Claim Game Server API. I've implemented like world's most simple matchmaking to this as well, or you can't really call it matchmaking. So when the next player makes a request, it will check a queue, so a managed queue service. If there's an existing session, if it exists, it will join that. If it doesn't exist, it will create one by claiming it and puts a message to the queue. So just to have a way for two players to connect to the same session. So yeah, we'll have the links in the chat. Pretty easy to search. Also, we have AWS samples, which is a huge set of example solutions for AWS in GitHub. So well worth checking out in general. Yeah, all the deployment instructions are there as well. All right, so recapping a little bit. So getting started. First of all, you need to identify your game server hosting needs. What kind of game server build am I hosting? What type of what resources do I need? So what are the compute resources? How many virtual CPUs I need? How much memory for a single game server? Maybe test out different instance types. Then you identify your game backend requirements. So maybe you're familiar with Kubernetes, you go down that road, or maybe you want a serverless approach, and then you decide how to host your game backend. Then you identify your latency requirements and plan for the global reach. So for let's say you have a turn-based card game or something like that, you probably don't need to deploy to all the 21 regions or 25 regions for the whole reach. And then if you have like a first-person shooter game, you might want to make use of all the GameLift regions available to provide a very low latency experience for the players. Yeah, then you can start with one of these examples or build your own. We have good documentation obviously available, some online courses as well. And then you can always reach out to AWS support for any questions through the management console, or if you already have an AWS account team, feel free to reach out to them as well. There's one additional thing that we wanted to talk about. So there's, and actually Alison can probably help you out with the chat with the details, but we have a program called AWS Activate. This is a way for you to get started on AWS at zero cost. So we provide you with 5,000 USD AWS credits valid for 2 years. You also receive business support. So there's $1,500 amount of business support. So this means you have 24/7 support access. And you also get credits for self-paced quick labs courses or sort of labs. You'll have the link in the chat, but this is the sort of identifier you need for IGDA to access the program. But you'll have more instructions in the chat links. All right, actually we are more or less at time. So thank you for joining the session. It's great to be here. I've been joining a lot of IGDA Finland events before, but never spoken in one. So happy to join this. If you can spare 1 minute, you can grab the QR code there or follow the link. You should have that also in the chat. I really want your feedback if you have time to give it. So I'll carefully read through that. There's a free comment section as well if you have any comments on the session. So yeah, feedback is greatly appreciated. All right, I think we'll move on to the questions and answers. So I actually haven't been able to see the chat, but I think Alison and Tony have been. So if there's any questions, just shoot them out.
Okay. Wonderful. Maybe we can get the rest of the team on the videos up as well, so we can see the whole team. Unfortunately, I'll keep you can't see me, but you can see the AWS. You're the heroes of this show anyway. Yeah. So any questions coming up? Any questions of your own? It was a lot of tech, but it was interesting tech. So yeah, let's get down and dirty with it.
Yeah, looks like so far no questions, but I think Alison can now share the link to the survey and also to the other resources. So if you have any questions, please drop them in the chat. We do have some time to answer them as well. Maybe I can then throw a question to you, Juho, as well. It's like, what do you see if you would start today? What would you choose? Would you be going with containers and building on that, or would you choose, for example, GameLift, or what would be the way forward if you would start fresh today?
Yeah, good question. So, well, I would say, yeah, if I'm a Unity or Unreal developer, or I have my sort of proprietary C++ engine, I would definitely go with GameLift hosting and see if it fits my use case. Most cases it will. So definitely this would be my approach. And in case you want to get more flexibility, maybe look at FLEETIQ, but I would definitely always start with GameLift hosting because it's a fully managed service. Typically, you don't have a lot of operations people in games teams, so you have the backend developers who are actually monitoring the systems 24/7. I've done that myself. So I would go with the most managed option and rely on the managed services for least operations and easiest way to scale globally across regions.
That's a
Great.
That's a very thorough answer. Nice. Any other?
It looks pretty quiet on the chat, but I'm also not seeing some of the things that I posted there, so I'm not sure.
Yeah, me neither. So if you share the links, we don't actually see them. So essentially the key things are the links to the GitHub repositories. I recommend checking those out, and obviously the survey. You have the link on the slide as well.
Okay, just a quick check. Did you see my test message in the chat?
Yep.
Yes.
Yeah. Okay.
Resharing all the material.
Yeah, like if you throw me the links, I can put them here now.
Okay.
That would maybe be the easiest.
Yeah, I'm able to post that this, I think, previously, so I'm going to try to put the links.
Yeah.
I wonder if it's because they are links or something like that. I'm not quite sure.
Yeah,
I'll put them.
I'm not sure either. That's a shame if we can. But we'll make sure that they come up and we'll share them. This is really cool. I was wondering, like, was Alison? Did you have something? It seemed like you were going to talk. Did you have a question?
I don't have a question. I mean, Juho and I were talking about using game server, like GameLift for esports platforms earlier, and I thought because there was a customer I was talking to who's doing an esports platform. So, Juho, if you could speak to that, kind of, is that an appropriate use, or what would you recommend for that?
Yeah, that's good question, good topic to cover. So typically with esports, you're obviously running server builds that are provided you. So you have the existing game, you have the server build. So you can't really integrate any custom code to it. So what you can do is I would probably go with GameLift FLEETIQ. So you would do the game session management on a very simple, let's say a Python application or something like that, as a sidecar process, maybe in a container. So you could use LFT container service, have a task that has this sidecar and the actual game server. And then you sort of integrate through that and have the game server as it is, because it's typically an existing game server build that you have.
Yeah. Okay.
Interesting stuff. Unfortunately, I was following, but there's like I said, it was a very thorough presentation. Didn't leave a lot to the imagination. It's interesting stuff though, and I'm pretty sure like in our company, our more like our CTO, unfortunately couldn't make it to the stream today, I think, but I think they are quite interested in this, and I'm pretty sure that. Or I know that you guys can be approached if you have any questions, obviously. So we're gonna make sure that we will have some emails or something that people can use. If you do want, and you can drop the emails or something in the chat. I don't know if they'll work. I saw a couple of Tony's messages there. Like, I don't know why the chat is being silly, but that's live streams. It is what it is. So, but yeah, if you can try to drop your emails there, the ones who are cool with being approached.
I would say the way to get started is that, of course, the links with all of the information, but the Activate Provider Program with IGDA Finland is signed up as a provider and IGDA Sweden as well. So it's a way to have, those free credits, the business support, the quick labs are all to help people get started at no cost with, removing all of the barriers. So you can get in there and start experimenting for your games and, start testing these tools and trying the different options as well that Juho put forward today.
Yeah, definitely. So this is something we're gonna be also doing. Like I said, there's the 3 events we're doing, and then the whole Nordic Games Conference, and then we will we'll unleash this sort of whole Activate program on all of you people. So all IGDA Finland and Sweden, indie dev specifically, I think, will benefit from this possibility of having a gander and a go at your servers. So that's really cool, and looking forward to that.
Yeah, and then maybe highlight as well, it's like we have Alison and Ed that can help you on the business type of questions on engaging you, and then me and Juho can engage you on these kind of technical questions on how to host your specific backend and what are the best options as well. And then contacting through Alison is most likely the best way to go forward as well. So then we can set up more deep dive meetings and go into your specific use cases and challenges.
Yeah, that sounds really good. Really good. Any other questions? Anything you want to add? Any famous last words, as it were?
I guess just thanks for joining the session. I guess we need to figure out the link sharing some other way, so they just don't go through the chat. I guess the main one for you guys is the activate information. So let's see how to push that through.
Sure. We actually got a question. Oh, sorry, Ed.
Yeah, I can read it out. So there was a question from Cam Storms. Hi, I just graduated as a game programmer from Taitotalo. What kind of educational courses are there in Finland for AWS, and what would you recommend? So obviously we have a lot of online content. So there's something called AWS Game Tech Learning Path. Unfortunately, can't share the link, but you can find it pretty easily with Google. I'll share it in a moment.
AWS Game Tech Learning Path. So that's something you can get started with. Obviously, the quick labs courses mentioned here available like with or without the credits. Some of them are also free. So these are good ways to start. We do have some collaboration with universities. I think Tony remembers better. There's at least 1 or 2 in Finland that actually do have some AWS programs.
Yeah, there's few. I can't remember on top of my head which of the type of like core, so higher education. They do have one of our like education programs, so they will give some of our courses as part of their normal course programs in their curriculum. So you can get like our solutions architect or developer or operations type of courses taken as part of your normal education there as well. We can double check on which the current status, which of the Finnish courses have that available right now.
Yeah, but this is something that more and more universities and also University of Applied Sciences is the So more and more both of those are on board, and we have a specific program for these educational entities to essentially provide AWS courses and AWS training.
Okay, that's a very good answer, and I hope Cam got some. I feel like that would give you the right direction where to go, Cam Storms, and good luck. Especially as a fresh graduate, it can always be a little bit intimidating to getting into the industry. So good luck with that, and a very good question. Anything else you guys wanna drop? Some dope knowledge, dope words you wanna try?
Yeah, I guess we covered more or less everything. So thanks for joining the session, and as said, we'll figure out
another question.
Yeah, there was just another question.
Okay.
I can read it out for you again. Hi Juho, when you are creating servers and client, do you prefer to use some multiplayer framework like Colosseus, Pomelo, or do you prefer to write everything by yourself?
Yeah, I guess this is something that like on AWS we don't have any preference on this, so you can do it any way you want. The networking is like can support any choice. The way I've built game servers is essentially sort of custom implementations over these sort of the basic TCP and UDP libraries. I think the easier way is if you have a good library to start with. It's probably faster, and I would recommend if you're using, as said, if you're using Unity or Unreal, you can run these headless on a Linux server. It's a really good way to have the simulation, everything similar as the client, and then you just sort of implement the networking and the sort of authoritative server functionalities on top of that. So same code base for both. It's pretty handy.
Okay. Cool. Cam Storms also said a thanks to you, Juho, for a good answer. So
yeah, thanks.
That's great. And now we got the links should be there in the chat right now. So anyone and everyone who's interested, please do have a look at that. Thank you, Juho, for a great presentation. Thank you to the whole team, Donny, Alice, and Ed, for this whole event. It was really cool. And as said, we'll be back next week. Same bat channel, same bat time. So I'll hopefully see you here. I'm gonna start wrapping up the stream. If you have any last words, I'm gonna try this for the third time. We'll see if that gets another question into the chat. Otherwise, we'll be going. So any words you want to still throw around?
No, thanks for joining.
Yeah, thank you.
Cool. All right.
Thanks, everyone.
Wonderful. For a really quick little session. Hello. See me again. Thank you for joining. Like I said, we're doing this three more times. So you're more than welcome to join next Tuesday when we're going to be talking about AI/machine learning. And that's going to be quite interesting. At least personally, I'm looking forward to that one. It's going to be the same place, same time. So see you in a week. And then again a week after that, and hopefully in the Nordic Games Conference. Thank you very much for joining us. All the best. Have a great evening, and let's hope that summer will be here soon. Summer and vaccines. That's all I'm asking for. Is it too much? Good night. Catch you later. Bye.
Thanks. Bye.
Thanks. Bye.